Hello everyone. My name is Katende Haman, and I'll be taking you through machine learning in general. So machine learning is a field of study where machines are being taught to learn from data without them being explicitly programmed. There are three types of machine learning. We have supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, this is where the model is trained on labeled data. And then in unsupervised learning, this is where the model is trained on unlabeled data. Then in reinforcement learning, the model is trained by directly making it interact with the environment from which the data is being collected. So the different models, the different types of machine learning are classified into the following. We have supervised learning is classified into classification and regression. Then unsupervised is classified into clustering, association, and then uh, clustering, association, and then decision 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 making. So in classification for supervised learning, we have the different algorithms that the model can use in order to make sense out of the data. We have models like the k-nearest neighbors. We have models like the support vector machine. We have models like algorithms like the decision trees. And then in regression, we have uh, popularly we have two regression algorithms. For example, the logistics and linear regression. Then in clustering, we have k-means clustering, and then in decision making, we have random forest and other algorithms. So the machine learning process. This is the process in which the model gets to be able to understand from the data that it has been given to it. So how is it done? So first of all, you choose the data set that the model is going to learn from. This is during the training part. This is the initial parts that you do. You first choose the data, then for example, you get the data from any data repository, for example, Kaggle. Uh, After getting the data, then you clean the data. This is applying pre-processing modules to the data. After the data is prepared, then feed it into one of the machine learning algorithms that you had chosen before. For example, k-nearest neighbors, such that you can get a proper prediction, such that your model is having a, a way that is properly predicting the data. So you iterate with this until you find you iterate among the algorithms until you find an algorithm that suits your data model. After choosing a best candidate, you deploy the chosen model and then feed it into the applications. After this, and then this is where, for example, this is where you do the actual testing. Remember, if you have a data set, it is advised that you use 80% for training, 80% of the data for training, and then 20% for testing. And then later, during the actual evaluation, you get the data that the model has not seen before, and then use it for further testing. So there are different machine learning algorithms, for example, the ones I've talked about, and henceforth, I'm going to go through each of them and then try to put more light on how they work. We have linear regression, and others. So the regression models, I'll begin with the regression models. These algorithms, remember the entire idea is, is the model able to predict from a certain given data set? So with regression models, we have two. We have linear Okay, there are many, but the major ones, we have linear and logistic regression. In linear, it predicts relationship between the variables between the independent variables by using a line of best fit. The closer the data points are to the line, the more the data is properly identified. Then with logistic regression, the model is used for classification analysis. This is because it is a probabilistic model, and it oscillates between 0 and 1. We have decision trees. Decision trees. These are supervised learning. It is a supervised learning model that splits the data depending on the question on a particular feature. For example, if you have a data set and they have the data set has particular features. For example, you want to get the best out of it. So for example, you have a car. For example, you're making a decision for a car. For example, like the one I have here, decision for a car. The primary feature is that if the car is red, for example, you prefer red cars. If a car is red, then you now look at the model. If a car is not red, look at which color it is. For example, if it is yellow, is it a Ferrari? If it's not, you don't buy. For example, just until when you get a proper decision that can help you predict the category of an item that help you predict the category of that item based on the particular questions about that feature. Further, we have ensemble learning. Ensemble learning is a technique that combines multiple models in order to increase their accuracy, such that if you combine that multiple models, you get a better way of classifying or predicting the results, or predicting further on that data set. The techniques in ensemble learning, we have a bagging, where the model is built in parallel bootstrap data set, and then average predictions. Bootstrap data set is just data that is sampled with replacement. Then we have another one. We have boosting. This model is built sequentially by improving on the errors that occurred in the previous models. So further, we have random forest. Random forest. This is a machine learning algorithm that combines multiple decision trees in order that the decisions that are made and on the different trees, ones that are made, for example, ones that have the majority vote, ones that are made with a majority vote are the ones that are considered. For example, if you have two trees that are predicting whether it's a 0 or a 1, and then you have like two trees that say two decision trees are saying it's a 0, and then one decision tree is saying it's a 1. So the random forest algorithm will take the one that has the majority vote. So it will take the 0 because more decision trees have coincided and have given you the same result. We have the k-nearest neighbors. This one is a simple machine learning algorithm that classifies new classes based on how near the data point is close, how near it is to a given cluster or category. For example, if you have two clusters, for example, in this illustration, the new data point, if we want to assign it to a particular category, we will first measure that its distance from each of the different categories, for example, the distance from category A and distance from category A, then the shortest distance will give us to which cluster this or which category this data point belongs to. We measure the distances using mechanisms like methods like the Euclidean distance method or the Manhattan distance method. So we get the shortest distance and it tells you which category this new data point belongs to, depending on the distance it is from the other data points. Another algorithm, we have the the support vector machine. So this algorithm works in a way that it splits the data by drawing a hyperplane among the different data classes. So this data plane, uh, is drawn and separates the two different classes or data categories. So if you want to know where a new data point falls, or which category to which that new data point falls, you just measure its distance from the hyperplane, or just look at it and see where it falls, whether it falls on the other side of the hyperplane or the other side. Meaning, if I have a new data point put on any point along or near this hyperplane, I can tell whether it's belonging to a particular category. For example, if it's belonging to blue or green, in this example that I have here. So with that, the support vector machine, it can help us make predictions to which the data points belong. So another one, we have the K clustering, the K-means clustering. So this one, for it, it's also an unsupervised machine learning algorithm, and it groups data. It groups the data points into clusters based on their priority, on their proximity to the centroids. Centroids they're just center points in a given cluster of data points. So how does it work? First of all, chooses the centroids randomly in the different data point clusters. Assign the data points to the nearest centroids, meaning it makes the different clusters depending on the different centroids in that thing. Then recomputes the centroids and repeats until convergency. For it's the centroid or the central point. It is the one that gives you which data points belong to that particular cluster. So meaning if you have a centroid here, all the data points around it will be clustered in that. So the applications of K-means clustering, we have customer segmentation. This is in finance. We have image compression, and then pattern recognition. And then the challenges with this algorithm is that it is sensitive to outliers, meaning if the data point is far away from any cluster, it may lead to inconsistencies. And then it is sensitive to outliers, and then initialization, and then non-free code clusters, meaning if the cluster is so far spread out, it may be hard to cluster depending on the given central points. With that, we can wrap up with the applications of machine learning. Machine learning is a very emerging, is a very strong technology, and it is used in different areas. For example, healthcare, for disease detection, for example, in retail, personalized recommendations, in finance, fraud detection, customer segmentation, and then, for example, in other areas like text mining, other areas like videography. Broadly, it can be used in different industries. The emerging trends in machine learning, we have the AI ethics, and then explainable models. Explainable models, they are just models that give reasons or they give reasons on what decisions they have made. Meaning, if they select a particular, if they give you a particular response, they have a reason behind that response. I stay as Herman Katende, Makerere, Computer Science. Thank you.